materials, different airfoil designs, swept plane forms, active control with flaps or morphing trailing edges. All of that's work that we do at Sandia. And then there's some grid work and reliability and other issues, but we've spent a lot of time on the blades. And it's actually a very hard problem. We've had, I've probably been in meetings with 12 different aerospace companies that have come to us and said, we know you know a lot about blades, we know everything about composites, and we want to get into making wind turbine blades. And then you go, well, okay, you get $300 a pound for your composites for 787, and you got to get $6 a pound to be competitive in this industry. And as you can imagine, the room's a little quiet. Maybe they leave early. So far, the success rate from aerospace into wind is 0. The only successful ones coming in have been boat builders who are used to the same price cost environment. So as part of our work, we design research blades, we contract with a company to have them built and demonstrate. So this was one of the first blades in the world with a carbon fiber spar cap. This is another one where we have off-axis carbon, so the blade will actually deform in a strong gust, right, to dump some of the loads, the blade lasts longer. This is one, it's a little hard to see, but we call it a flat back airfoil. It's actually this thing over here. It makes it structurally stronger without sacrificing too much aerodynamically. This is a boring chart. What you can really look at was we took a blade from the 90s that was 750 pounds and managed to make it 289 pounds and actually a lot stronger. And to a question, I think it was Bob's earlier, you know, what about watts? Well, we said earlier, watts didn't do that well long term because if you wanted better wind, you'd use a taller tower to get up to where the better wind was, and that doesn't work as well for a watt. We're very bullish at Sandia on watts for offshore wind because you don't have trees and buildings and things along the water, so generally the wind shear is much less. Okay, so the wind speeds at lower elevations above the water are much better. And if you want to go to a floating platform, now this design doesn't look very good because you've got all your weight up here, right? So you have a much lower center of gravity with a vertical axis machine, which should decrease your platform costs. And Sandia has a lot of experience in bots, so we're doing research on that right now. This was a test turbine that Sandia designed and was actually built in Bushland, Texas, just west of Amarillo. If you drive down I-40, this was visible for many, many years right near the Cadillac stuck in the dirt. And so this, you know, this was state-of-the-art about, I don't know, 1990, something like that. So we've got a little update to do. This was actually an all-aluminum turbine. But I think vertical axis is going to be well offshore.
Could our oil platforms be transformed into 8-meter platforms?
Yeah, and we'll get that a lot. It's kind of the aerospace to wind example. I mean, the offshore oil and gas guys are very good at what they do, but they are operating in a cost environment drastically different. So we are leveraging all the experience we can from that industry, but you know, you can't drop $500 million